Hey, how's everyone doing? We're going to do another devlog today. I'm going to show you all of the blueprint enhancements I've made, all the functionality I'm building into the game. We do have some test props. These are custom props that have been created for this game. However, the focus isn't on environment art yet. It's really still on developing. So where are we at? What kind of functionality do we have in the game? Well, I've really just been working on an interaction system. So we have this cursor now. And as you can see, when we look at an item that can be interacted with, we get that nice little animation and we get some text displaying on screen for what that item is. Same thing here with some extra functionality on the ATM. You can see if there's an emission map on our particular object, then it lights that emission map up. So when we look at that, it lights up. And for now, it plays a sound. I don't know if I'll keep the sound. That's nice. And then same thing with the door. And now we get a prompt to open the door. So if we actually press interact, we get that. So very simple. But the nice thing about this is this has been built with what's called a component, an actor component. So let me just open up a little notepad here and start to explain some things. So let's take a screenshot. And this is going to be a little messy, but let's grab our screenshot here. Let me just grab a pen. Okay. All right. So I want to talk about a few things that I've learned so far. Now, with something like environment art, I know a lot and I'm very confident in my level of knowledge. With something like blueprints and visual scripting, this is still new to me. So I'm still learning. These are the concepts that I'm starting to grasp. So if you have feedback, if you're a long time Unreal Engine user, developer, and you want to give me some feedback, please do so. But this is what I have so far. So in our game, we have these things called actors. Now, actors is a term that encompasses just a lot of different stuff. This could be, for example, our character blueprint. It could be, let's see, a static, well, not a static mesh, that's a component. It could be our item blueprints, okay? Just general blueprints, things that go into the scene, all right? These are actors. Now, within actors, we have these things called components. And a component can be something like static mesh, the actual mesh itself, and other things like cameras, and lights, all right? These are all components that can be within an actor. It's important that we understand this basic terminology. All right, let me just clear this so far. So we have actors, we have components. When we're scripting in Unreal Engine, one of the big things that I ended up having to do was, of course, we have functionality within actors. So an example of an actor is our first-person character. That's an actor in our scene. But as we develop the functionality of the game and various game mechanics, we need to have actors communicate information back and forth with other actors. Great example of that in our game here. Let me just grab my controller. We have our first-person character walks up to this ATM, and a lot of things just happened. We looked at the ATM and communicated with the ATM that we're looking at it. The ATM communicated back to us some information about what it was. This text, for example, where it says use ATM. And we communicated back to this little cursor to animate. See how it animated that little interaction and for the text to appear? We're just going back and forth quite a bit just in that simple little interaction right there. So whenever we need actors to communicate with each other and to have functionality, we need to build a structure for that. So again, we have actors just like our first-person character right here, all right? Our first-person character is essentially just a camera at eye level, all right? That's my little camera. This is our first-person character, okay? Our first-person character is an actor. Now, how do we build functionality onto that first-person character? Well, we could, for example, come in here to our content drawer. Let me just go to game. Oh, what in the world? blueprints, characters, player character, first person. This is our actor, all right? So we could go into the blueprint event graph, and you can see I have some functionality built into this. Now, I have my look, movement input, sprint, jump, crouch, zoom. This is all just the controls for my character. But you'll notice I don't have anywhere in here the functionality of looking at stuff, like when I look and start to communicate with an actor in the scene. That's because I've built this functionality in something called an actor component. So let's go ahead and look at that. Now, the benefit of having something like an actor component, I'm just going to abbreviate this as AC. The benefit of this is I can build out functionality on top of my actor, in this case my character, in kind of a modular way. So let's try to draw a little puzzle piece here. This is my actor component, and the nice thing about the actor component is I can simply attach it or detach it from my first person character, and it comes with all of the functionality inside of this, all of the code that makes this actor component work. So let me show you what that looks like on my first person character. Like I said, you can have components within actors, and if you look down here, remember my little puzzle piece? We have a little puzzle piece icon for an actor component, and in this case it's called Blueprint Interaction Trace Component. So this is all of the functionality that helps my character look at stuff in the world and identify what it's looking at. So all we have to do is, let's go to Blueprints, and under Blueprints we have a folder called Components that I've created. This is where all of the actor components will live in my scene. Now, the nice thing about this modular kind of workflow is I can build all this functionality in this little puzzle piece, and I can attach it to different things. In this case, I'm just attaching it to my first person character, but something like the interaction object component, which I'll get into, I can attach that to every single interaction object. So I just create the code once, and then I attach it to all of the different places that need this functionality. So stick with me. Let's look at our interaction trace component. Remember, I've added this to the first person character. So the way we do that is you can simply right click in the content drawer, go to blueprint, you can create a blueprint class, and the class is just called an actor component. And once you create that, then you get this little puzzle piece icon and you have an actor component. After you create an actor component, you can add it to an actor just by coming up to here to add. And you can search for, my pencil's not working. For example, actor component underscore interaction object component or interaction trace component. That's what we have here, all right? So once we open up that actor component, I double clicked on it, opened up here. This is all the functionality that I'm creating for the trace that happens from my blueprint first person character. So first, let's look at the event graph here. Now within this, I have a few different functions. Now a function is a little bit different from an actor component. Within both of these, within actors or actor components, we have what's called an event graph. Now, an event graph is where all the logic happens that tells this particular actor component or actor the functionality, the scripting, in this case, the visual scripting, the different nodes that tell it what it does in the game. And within this event graph, you could have something called a function. Now, I come from the world of Blender. That was the first 3D software I really understood. And within Blender, for example, if you're creating like some shader nodes, just pull up an example here. If you're creating these shader nodes, you could, for example, hit Control G and create a group. You can hit Control Tab to jump out of that group. And within this little node group, we have an input, which is our vector, and we have all of these different outputs. And we could control those inputs and outputs if we hit Tab to go into this by dragging out new inputs or outputs. So for example, we could have let's just add a value here. And this value could be a new output. All right. Once we go back to Control Tab, you can see we have that value. So a node group, and you might be wondering, why am I showing you this in Blender? We're talking about Unreal. Well, this is for those that are familiar with Blender. I'm going to help unlock something in Unreal for you. So we have these little node groups. They have inputs and outputs. Now in Unreal, it's no different. In Unreal, we have these things called functions. Now, a function can be found within whatever event graph you have. We have this little area over here, a little tab called functions, and you can add new functions. One example of a function is get trace start and end. So let's just double click on this, and that opens up our function. This is a function I added. It's called get trace start and end. And you'll notice it's very similar to what we had in Blender, where we had the start and end point. I'm just gonna put away my pencil and start using my mouse here. It's very similar. We have inputs right here, and we have outputs. And within this little function, this little node group, I'm building certain functionality. So if I go back to the event graph, you could see right here on event tick, I have get trace start and end. Now event tick is something that happens every frame, but don't panic. I've optimized this a little bit in our actual, I think it's class defaults. Yeah. In our class defaults for this particular event graph, you could go in and you can change your tick interval. So this event tick isn't happening every frame, it's happening every 0.1 seconds. So you can kind of slow down your tick to be a little bit more performant if that's something that concerns you. I'll talk about performance and optimization in just a little bit, but we have our get trace start and end. We double click on this. All this is, it's kind of like a group. This is a node group where we get some functionality happening. And if you've looked in my previous devlog updates, I've gone into how to get in start and end point for a line trace. That's all this is. This is just getting 2 points in 3D space. We are outputting the start location and end location into another function, which is called find interactable by trace. And in this one, if we double click, just another node group, and this is where our line trace is happening. Again, I went into this in a little bit more depth in a previous devlog update. Basically what's happening is we have a line trace, which is shooting out a ray from the start and end point we have here into the scene. And this ray is, if it hits anything, in this case, if it hits something that has a particular trace channel, then it will say, hey, I hit something. And then I start to get some information about that. I store what object that I hit, and I check some things like, is this object that I hit, is it not equal to something I looked at just a second ago? So if I look at one object and then look at another one, it'll check, is this the same thing I just looked at? And this is all just some optimization stuff. I'm not gonna go crazy in depth into what I did here. Could this be optimized? Yeah. I know for a fact it could be optimized, but this brings up another good point. This was probably the best piece of advice I've got up to this point, and it was from Ryan Laley, who runs another YouTube channel, which I definitely recommend. He's in my list of recommended learning material that's down in the description. Talking about optimization, he was talking about how for game optimization, there's some low-hanging fruit. Textures and mesh in your game, that's where you're going to get the most bang for your buck as far as optimization goes, especially textures. Textures tend to be the culprit when it comes to low performing optimization. If your game's running slow, first thing you should look at is your textures. Beyond that, you should look at your mesh and certain things that you could do to optimize your mesh as well. However, Ryan was talking about the other side of optimization with code, with our visual scripting here, our nodes in the blueprints. There are always things we could do to optimize how things run. And I could easily spend, believe it or not, 6 hours trying to get down the way my code runs by 6 milliseconds, all right? And those 6 milliseconds are very valuable but there needs to be a balance. A lot of the best optimization you can do in code, honestly, is just finding ways where you are working faster, you're keeping things organized, and you're working in a way that allows you to come back to your project and to understand in a clean way what you were trying to accomplish. Sometimes I'm going to value that a lot more than working for an unbalanced amount of time just to get a couple milliseconds of performance. Now, some of you may not share that opinion, but especially in these early phases of trying to understand blueprints, I'm all open to feedback, and I've jumped on calls with very generous viewers who have helped me understand more performant ways of working. But for now, with this being an indie project, I'm the only one working on it, I really have to prioritize finding ways of working that make sense to me and that are sustainable for the long haul, that can be expanded upon, and just building a good foundation. So in this particular example, instead of using a blueprint interface, which I'll talk about in a second, I could cast to this particular interactable item. And there's a bit of a myth out there in Unreal Engine land where people say never cast to anything. Never cast to anything because it loads stuff into your memory and it's really bad for your project and it's not optimized. Now, I do try to avoid casting when I can, but more important than just the rule of never cast to anything, you should really understand what casting is. And basically what it is it's creating a hard reference to the object that you're casting from. So for example, if I was my first person character and I cast to an interactable item, what that's going to do is anytime my first person character exists, it's also going to pull the interactable item into memory and load that into the game whenever I have my first person character. And that might sound like a really bad thing, but if I always have an interactable item loaded into the game anyway, then it's really not doing anything bad because I have that interactable in the game to start with, because I'm looking at it. That's the whole reason I cast to it, is because I'm looking at it. So there are things that help you be more optimized in your game, for sure. Don't get me wrong, there are definitely things we could do to be more optimized. However, this applies to not just blueprints, but just my career in 3D in general. If I ever come across someone that gives me a hard, fast rule and says never, ever, ever do this in any situation, I tend to be a little bit skeptical, just because there are not a lot of hard, fast rules in our field. There are rules, sure, but I see them more as guidelines that can be bent or broken if you understand why you're breaking the rule and why you're making that particular decision. So that's a little bit of a tangent, but I've come to learn a lot of beginner tutorials will say never ever cast ever. And I've really appreciated the people that actually help me understand what casting is and what the alternatives are and the pros and cons to both. But anyway, that's a little bit of a tangent and a ramble there. But let's talk about what blueprint interfaces are, because that's what we're using here. So we have our functions, which are kind of like node groups. We have our actor components, which can be added to actors as kind of a modular way to build functionality. But we also have these things called blueprint interfaces. All right. So let's see, how do I draw this? Let's have our actor here. All right. This is our first person character. And added onto our first person character, we have our puzzle piece, our little actor component. Oh, that was a terrible one. All right. So we have our actor component that's giving our first person character some functionality. And then over here, we have an item in the scene. This item is a wrench. You can see it kind of over here. It's on top of that platform. I'll show you a better view in a second. And this wrench also has a separate actor component that gives this wrench some functionality as well. So within this actor component for the first person character, the functionality is, let's see if I could draw an eyeball here, is functionality that says, okay, line trace, you can look at something and get some information about what you're looking at. On the wrench, we have an actor component that builds in some functionality that says, hey, when something is looking at you, identify that it's looking at you, receive some information, and then tell it some things. Speak to it. So we'll do a little megaphone here, how about, or a volume. Speak to whatever's looking at you and tell it the text for what should display, and carry out whatever functionality or carry out the operation that you have stored within yourself. So if you're a door, then open. If you're an ATM, then turn on and eventually bring up a menu to let the character look at their bank account or whatever it is. So an actor component is added to this item. And by the way, this functionality could also be directly added to that actor. An actor component, again, is just kind of a modular way of working where we can add code, not just to one actor, but to a lot of different actors. Now, what about a blueprint interface? And by the way, I'm giving you some terms here, some vocabulary. This video should not be the only research you do into this vocabulary. You should be looking up actor component, go look up blueprint interface. Event dispatchers is another one you should be learning about. I'm just giving you kind of an overview of what I understand and how I started to get these things working together. So a blueprint interface, I've heard it explained as kind of like a contract. So we have a little document here, and I liked that explanation because it clicked for me. A blueprint interface kind of has these rules or these terms, and different parties agree to them or learn how to use this. Okay, I've heard it explained as a contract. I've also heard it explained as like a messaging service or a language. So our actor component is part of our first-person character agrees to these terms, and so it can start using the blueprint interface. The actor component on our actor here, the wrench, also agrees to these terms in the blueprint interface. And before you know it, we can pass information back and forth between these two things. So for example, our first-person character walks up to the wrench, sees that it's a wrench, and can start carrying out operations within the wrench, whatever that is. I think the door is another good example. Just pull up our game here. Our character walks up to a door. Through the blueprint interface, we get the information, this message that says open door. We also got the information for when we were looking at it so we could animate our cursor there. And when we press interact, the door gets a message to carry out whatever functionality it has. In this case, it's very simple. It just plays a sound. It's just a placeholder sound and does a little animation. So that's an example of all of this at play. So let's just dive in once again. Let me go grab some water. I'll be right back. This is a reminder, go drink some water if you haven't already. So what does all of this look like in practice? Our actor components talking to our other actor components through a blueprint, first-person, through a blueprint interface. So within our game, we have blueprints, we have our actors, we have our components, and we have our interfaces. I also have a folder just for my characters. Right now, it's just my first-person player character with the first-person player controller. Okay. Within components, let's take a look at that. We've already kind of looked at the interaction trace component. Again, this has a few functions, which are kind of like node groups. I have the trace start and end, and then I have the find interactable by trace, which is where I'm actually doing my line trace and I'm getting the hit results, breaking that down, and I'm figuring out what I'm looking at, my hit actor. And I'm sending a look at blueprint interface. So if I go to my interfaces, you could see I built an interface called blueprint interface interact interface. So if you open that up, I have just two functions within this. I have look at and I have interact. All right, you can add a new function just by going here and adding a function, giving it a name. So within my actor component function of the find interactable by trace, I'm doing a line trace and I'm sending a message to what I'm looking at. I'm sending that message through my blueprint interface. So you could just get this by typing in look at. All right, and then I just got, let's see, look at message. Okay, that's what this is. So it's sending a little message to whatever we're looking at, and it's asking it, hey, did you agree to the terms of this blueprint interface? Do you speak this particular language? And in this case, what I'm looking at, let me go to that component, interaction object component. Weird, it's not opening it up. Compile here. All right, weird, it wasn't opening, but I figured it out. Okay, so the interaction trace is sending that message, and it's saying, hey, do you speak this language? Do you have this blueprint interface? And in this case, the component that is added to any interactable object, go to the event graph here, go to interfaces, you can see we have look at. So if I open that up, this is what happens if something sends it a look at message, all right? And in this case, all of this logic right here, let's just look through it one piece at a time. The first thing it's gonna do when it's looked at is it's actually gonna send another message, all right? And it's sending another message to the cursor. Remember in the game, when I look at something, our little cursor animates to show that we are looking at an interactable object. So the component on our blueprint first person character, the line trace, it sends a message to the actor that it's looking at. And the first thing that happens on that component that's on the actor that we're looking at, it sends a message to the interface, and we'll get to what that says in a second. But basically it just says to the interface, hey, or it's called a widget. It says, animate this, so we could tell that we're looking at something, all right? And then it sends into a branch. A branch is just a Boolean piece of logic, basically that says true or false, on or off. And the condition for this, the thing that says whether it's true or not, is this this little variable that's called isLooking. How did we create this variable? Well, in our blueprint interface, under look at, we have down here, we have an input, and it's called isLooking. So when we did our line trace, we plugged in this input for isLooking. This input comes from the return value on our line trace. So all that means is when we did a line trace and we hit something, if we're currently hitting something, then we turn on that isLooking, so it's true. If we're not looking at something, if the line goes away from that and shooting off into space and doesn't hit anything, then it's false. We're not looking at something. Why is that important? Well, we're using that to tell our interface to do a few things. Number one, it's going into the cursor, the widget. So it's saying, are you looking at this right now? Okay, cool, animate so it's open. If you're not looking at it, animate so it's closed. We're also using it for this branch right here, where it says, are you looking at this right now? Okay, go down the true path. Are you not looking at it? Go down the false path. So what happens on this true path? Well, first thing we do is we can play a sound. And this sound is what's called a variable. When I click on this wrench, for example, I can go to my component and I have this exposed variable called onSound. And in this, I can add a sound. Let's just add, let's add a random cue that I know that I have in here. Let's add on, and you could probably guess for my off sound, I'm gonna add an off cue. So let's play this. And now let's listen and see what we could hear when we look at our wrench. All right. Now I made this a variable that could be changed depending on the object because I might want like a different sound for the wrench, maybe like a metal clank. But you could see I have the option to add that sound, and you could see where that sound is being created or played in our interface here, or in our script here. All right. So we're playing a sound if we're looking at it, and then all of this, create a dynamic material instance, set material, set a parameter. What that is it's identifying a material in this particular object, and it's seeing if it has a parameter for an emission map, and then it's setting the emission map value. So that's relevant for anything that has an emissive map and using a particular material. For example, when I look at this ATM, it turns on that emission map, which shows this screen. That's just kind of an optional little bit of functionality that I built into the game so that I can have that. Let me, you know what, I might as well show you what that looks like. Let's go to this object. Let's hit Control B to bring it up here. And actually, I'm gonna go to Game, Materials. Let's see, how much do I wanna show you here? I mean, I'll show you whatever you wanna see, but it's just how much complexity do I wanna get into. I created a master material for any PBR object or any PBR material. So I have my base color, my channel packed ORM map, my emission, and my normal map. And all of these are what are called parameters. So they could be changed within a material instance. I also have a parameter for emissive. This is set to 0. If it's set to 1, then whatever the emissive map is has an emission value of 1. This could also be set to beyond 1. So it could be set to 5 for 5 times the emissiveness. So that's a parameter. A parameter can be changed within the logic of a blueprint. Okay, so anything I'm setting as a parameter can be changed, and I'll show you how in a second. I also have this little setup with texture coordinate, multiply, floor, which is kind of like snapping and divide, to have the option of pixelating my mesh on the fly, or pixelating my materials on the fly. This is also a parameter. So that's the master material, but let's look at one of the instances. Okay, let's just save whatever I did there. And this is, you could tell I have material master PBR. This is material PBR ATM. This is an instance of that normal one, of the main one. And you can see we have all of my parameters. I can change the base color, the emission, the normal, and the ORM channel pack text. And anything I check here is saying that, yeah, I want to change this from the default. So for example, by default, my textures are pixelated. I want to change the resolution, and I can set the max resolution on this particular material instance. For example, I could set this to 128. Save this. If we go back and look at our ATM, you can see it kind of has a pixelated lo-fi look. Now, I'm not going to do that in this particular case. I'm going to put this back at, let's do like 2048, just so we give it back its full resolution. And this is just a preview. This is a little bit of a tangent, but I just created that parameter because I want to be able to quickly pixelate things to see what kind of the lowest text resolution I can get away with is. There are other ways to do this, but this is just a way that I find to very quickly change all the maps. Anyway, so back in the logic, for an interactive object, I have that parameter of the emission value. So when I look at something, I'm getting the component by class. So within my look at object, I'm getting the static mesh component. And in that static mesh component, I'm getting a material. And then I'm creating a dynamic material instance. So I'm creating a new instance of that master material. And I'm setting the material, the scalar parameter value of the emissive parameter name, and I'm setting it to 1. So all of that basically just tells my game, when you look at something that has that emissive map, just set the emission to 1. I could change this, for example, to set the emissive value to 10. If I compile and save that, now when we play and we look at this thing, it's way brighter. So we're just setting the emissive value to 1 when we look at it. Now remember, we had that branch at the beginning, if you're looking at it or not looking at it. When I look away, when I'm no longer looking at it, I'm playing the off sound, and I'm setting the scalar parameter value of that emissive parameter back to 0. So then it's just turning off the screen again. And that's all of the look at functionality for this particular actor component. Remember, we can build modular little bits of functionality within actor components that could be attached to actors. So this actor component is attached to every interactable actor in my scene. Remember when I sent a little message to the widget, the interface, our little cursor? Let me show you that now. So if I go to Game, UI, Widgets, Cursor, we have all the images for my cursor. We also have this little widget blueprint. So this is my widget blueprint. I have an animation in here where if I select it, you could see through time, I'm animating my little cursor and I'm animating in the render opacity of my item, of my text, right? Now this text, if I select the text right here, you could see, let's see, the text is set to is variable along with each, oh, sorry, just the text, I guess. Yeah, along with each image here, all right? So top, right, left, bottom, these are all just little images, and then the text itself is set to a variable as well. Why is it set to a variable? Well, we can go to the event graph for this widget, which you can get to just over here. And now, under variables, we have that. We have each object, and we have our text, and all of these are variables, which means they can be animated. So, within this, the first thing I do is on event construct, when this text comes into existence, okay, I'm just setting the render opacity of the text to 0. So when it comes into existence, the text is not visible. And then I have a function, because this particular widget speaks the blueprint the blueprint interface for interact. Remember, we have look at and interact. We have those functions within here. So let's go to the look at function. Remember, when I look at something with my character, that item sends through the blueprint interface some information to my widget, and this is where it's receiving that. So, are we looking at this? Yes, okay, we're doing some things. For example, we are taking our interaction text and we're setting it to a variable of whatever that text is. So if I go back to my game here, if I select the ATM, for example, and go to my blueprint interaction object component, my actor component, I can change the on sound, I can change the off sound, I can also change the interaction text. So instead of use ATM, I could say, maybe this is how we save the game, right? I could say save game. Now when I look at the ATM, it says save game instead. So this is just an exposed parameter. I'm gonna change it back, use ATM. And in our widget, if we're looking at it, I'm saying set the text to whatever that variable is, all right? That exposed variable. So now it's setting that, and then it's gonna play a little animation. What animation is it playing? Well, remember, I created an animation within my widget here, the opening up animation. So when we're looking at it, play that animation. When we're not looking at it, go ahead and play the animation reverse. Play the animation, cursor opens up. When we're looking away, play the reverse so it closes. You can see that happening in real time. Watch the little cursor, right? And we're returning, that's just the end of this little function node group. So, back to our overview here. We have our first person character, and I'm sorry if I'm just repeating myself here. Learning takes repetition. We have our first person character. To that, I have an actor component, which has all my functionality for the look at line trace. When I look at something with my line trace, I'm using a blueprint interface to pass on that information to an actor component that's been added to every interactable item. That actor component then, in turn, takes more information and passes it on through the blueprint interface again, all right, and passes it on to our widget, which is our cursor, for example. So we have that little cursor. When we look at something that is interactable, then we animate our cursor and we do all sorts of other stuff. So the general principle is here we have actors, we have actor components that contain functionality for actors, and then we have blueprint interfaces that help us communicate certain variables and all sorts of stuff through those actor components. Now remember, I said we could add functionality onto actors directly, and this is the benefit of having a blueprint interface. because we can have all sorts of different actors use the same interface. That's why this is useful, because they don't have to all be like within one parent-child hierarchy, for example, where they inherit from a parent. You could speak to anything that has this blueprint interface added to it. A good example of that is when I look at my door, the actor component on my door is doing everything we've talked about. It's displaying the name, it's doing the cursor animation. But then when I actually interact with this, it has its own set of functionality within the door actor itself. So if I open up that, if I go to game, blueprints, actors, doors, this is my door actor. If I open that up, you can see I have this whole event that's done within the event interact. Now, why did I do this within the door specifically? Because one of the limitations of an actor component is you can't have time-based functions. You can't have time-based functionality. So, for example, a timeline, playing an animation, that's based in time. So I'm doing that in the actor itself. So when I interact with this door, so if I go to my object trace, let's see, my event graph, I also have this input action interact. So when I press whatever button is to interact, it's going to send a little message to whatever I'm interacting with through the blueprint interface. And the target is the last looked at actor. Where am I getting that last looked at actor? Well, in my line trace, I'm storing whatever I looked at, I'm setting that as the last looked at actor. So if I looked at bottle, it will store that information. The last thing I looked at is that bottle until that gets cleared. And it won't get cleared until I look at something else. So the last looked at actor is stored. All right, where am I? Okay. And then I send that information with that as a target. So when I press interact, I'm sending a message to that door. First thing I'm doing is clean this up a little bit here. First thing I'm doing is I'm playing a sound, just the door opening sound. It's just placeholder for now. And then I'm going into a branch, all right? If the door is not open, so if it's closed, then it's going to set it to open. It's important so we can toggle back and forth. So if it's closed, it's gonna say, okay, now it's gonna be open. And then it's gonna play this timeline, which is just the animation of the door opening, okay? And then it's going to set the relative location of the door with this animation timeline driving the X location of the door. So what that means is when I press interact, it's going to animate the door opening and play a little sound. Now, we've done it once, but what about when we click on it again? Well, it's gonna say, is this not open? Is it closed? All right, false, which means it's open. Okay, now set it to closed. We're changing a variable. Set the variable to closed, play the reverse of that animation, and same thing, set the relative location. So now let's look at the timeline animation itself. We just have two values, one that happens at time 0, and it's set to 0, and then another one that happens at time 1.1, and it's set to -90. What's -90? It's the value, in this case centimeters, of how much it's animated on that x-axis. A timeline, really, really useful, all right? So let me just change this a little bit to show you an example, all right? So let's say we add another keyframe here. Let me think about this. I want it to kind of like pop open and then continue opening. So let's just put this, let's right click, set this to auto. Let's change all these to auto so it's a little bit smoother. So I think that should pop open and then maybe we add another one that's like, I don't know, let's see what this looks like. Pop open and then continue. In my mind this works, let's just see. Let's compile, let's try opening the door. Yeah, it was a little much. And it's not gonna work in reverse. But you could see what what I'm doing here. All right, let me go ahead and just grab these two and delete them. So now we just have the normal door animation. Let's compile and let's try this again. Yeah, so again, that's just our timeline within the event graph for this particular door object. So now let's recap everything. All right, and then let's talk a little bit about the future and where my game project's going. Again, repetition. That's how we learn. We have our actors. We can add functionality to those actors' event graphs directly in the case of our door, or we can add actor components, which are reusable modular little bits of functionality or scripting that could be added onto actors. So actors and actor components, both of these have event graphs. Now it's important to note that an actor component or a function cannot have time built into its logic. That can only be added to the actors themselves, like the door. As far as I understand, please correct me if I'm wrong. Then we have blueprint interfaces, which are used kind of as contracts to get everyone on the same page and to be able to pass back and forth certain variables and information to each other. For example, my first-person character actor component looks at something and passes the information what it's looking at through a blueprint interface to then start interacting with whatever it's looking at. All right, so we have actor components on both sides of the equation, or we can just build functionality directly into an actor. Then we have things like widgets, which are kind of displayed on screen. These can also have an event graph where certain things are communicated with it. So that's how I animated the widget when I looked at something interactable. That's how I change the text depending on what I'm looking at, through variables that are exposed and can be controlled. So that's a lot. What I'm gonna do with this one, because we're starting to pick up momentum and this is starting to be too much for me to explain, like I can't look at every single node in one video anymore, or each video is just gonna get longer and longer and longer until we're here for hours and hours. So instead of doing that, I'm explaining the general concepts, and I'm going to publish my game as of right now, all of my files, my project file in my Patreon. So if you want to dig in and take a look and try to learn, or if you're experienced with this and you want to optimize, you want a little project optimizing what I've done, then you can go download my project files over on my Patreon. It's just going to be $5 a month to get access to that. You also get access to all of the assets that I'm creating for the game. For example, this ATM, I'm going to have a lot of different assets for this game that you can also download and use in your own projects. So I'm giving you the rights to use them in your own games if you want to. All of that can be downloaded as it becomes available over on the Patreon. Also, you're just supporting this channel. Hopefully that's been an insightful devlog. I kind of have two paths I can take with these devlogs. Number one is the path we're taking now, and that's where I just share everything. I just open up the project live and I just talk about it. The benefit of this is you get to see a lot more. The downside of this is the production is kind of messy. Like I'm just here scribbling on images and I don't have like high production value where I'm making this like an engaging piece of entertainment for you to watch. So that's the first route, pros and cons. The second route is I could actually script out something that's going to get more views and it'll be a little bit more engaging to watch. But the downside is it takes me a heck of a lot longer to make those things, if I make them at all, and I can't fit as much good information in those because so much effort goes into scripting it and the pacing of the video and to make it engaging. So I hope you appreciate this route. I'm choosing this route because it lets me give you more information, but we're taking the hit of this isn't going to be as engaging and kind of overall exciting to just the general viewer. So if you could help me out by, telling the algorithm that this is interesting for you, go ahead and like the video. Please subscribe if you're not already. And again, the best way, hands down, to support this channel is to go to my Patreon, check out the perks, download this project file right now. I'm gonna make it available so you can start to look at what I'm doing in here. Yeah, and that's it. Devlog number 2 is done. Are there more optimizations I can make? Definitely. Please leave comments if you have optimizations. I've made a conscious decision to use things like Blueprint interface and to try to use tools that make my project a little bit organized, more organized, even if it's at the cost of, not 100% absolutely optimized. I'm trying to find ways to work that I understand and that I can comprehend and that keep my project organized so that I can come back to them later and add more functionality going forward. All right, thanks for watching, and I'll see you in the next devlog update. Thanks.